Hello guys, welcome back. Today we start a week. Usually a hard problem. Sum of k-mirror numbers. The statement gives us the definition of k-mirror numbers is the positive integers without leading zeros for sure. Yeah. That reads the same from forward and backward. That means palindrome, right? Palindrome. In base 10 as well as in base k. In base 10 is easy, but in base k you may need to convert from base 10 to base k and check it manually using like ways to string and check as a string. For example, 9 is a two-mirror number. Okay, the representation of 9 in base 10 is 9 already, is palindrome, right? In base 2 is 1001. In this palindrome too, you can see that the read it from backward or forward is the same. On the contrary, 4 is not a two-mirror number. Although 4 is palindrome in base 10 in decimal, but actually in base 2 is the 100 is not palindrome, as you can see. Alright, so give the base k and the number n. Return the sum of the n smallest k-mirror numbers. That means we need to find all these smallest k-mirror numbers. I mean, we need to find n number. Oh, sorry, I don't know how to spell it wrongly or not. Mirror.
Mirror.
Mirror, yeah, mirror. For the first example, you can see n equal to 5. We need to find the first 5 k2 mirror number, right? That is 1, 3, 5, 7, 9. You can see the base 2 is a palindrome, so the sum is 25. This one, 3. You can see this is the first 7. The first 7 3 minor mirror, three mirror numbers. Okay, the constraints 9. Okay, 9 from 2 to 9. Yeah. And it's really small, as you can see it's about 30, right? Why actually I don't have a general solution if n is too large, but if n is like 30 is really small, so you can think about the brute force approach. And I believe I have a strong belief that the maximum number, I mean the 30 number, that is the maximum one, is not too large, and like we can iterate, but we need to iterate smartly, not like look from 1 to the last number. Like you can see that actually the problem give us a hint here is long. It can exceed the sum. Sorry. Can see the sum cannot exceed this number, and the sum of 13, the first 30 is much smaller than this. So it's about I believe that it's about this kind, maybe up to this one. I just have a strong belief that because it's really small. So yeah, as I say, we cannot iterate from 1 to the last number, like billion, 1 trillion. We can do it smarter, as you can see in both k base or 10 base. Okay, I will use 10 base for simplification. Yeah, for example, 10 base like this number or this number. It's palindrome, right? It's mirror number. But actually you don't want to iterate from, you don't need to iterate, you don't have to iterate from 1 to a certain number and check every single integers in palindrome. But you can do it without check, by just create a half, the left half of a number, then reflect it. Like you got 30, then you can reflect it into 31. Okay, and append it. You can see it's palindrome. But this case is like this is the even digits numbers. So, and actually you can make an even palindrome number by putting an arbitrary digit into the between of the two sides. Okay, for example, you can put 0, 1, 2, 3, and 4. Like all of that is a palindrome. So the problem here is, so you can see instead of a solution like h, which h is the maximum number. Okay, number k mirror. You can simply do is square h by iterating a half side. Why square here? Why square root here? Because you divide, you only get a half, so it's maybe like the square root. Just square root to reduce a half number. Maybe like this. This is like 1000, but actually you only need to iterate like 100. Sorry, this may be up to like up to number, but if we iterate a half, so we only need to iterate to as most 100 number. All right. So the solution here is in my solution. My proposed solution here is to iterate a half. Iterate from one digit number to 2 to 3 to 4, then duplicates and reflexes. So, and after that we check in k base is this palindrome, and if it is, just sum it, count to the answers. Okay, now we're gonna count it. All right. I gonna iterate. You can either iterate in base 10 or base k. It's only possible, but I prefer use base 10 here. Okay. Digits from 1 to I don't know, but maybe 10. No, 10 is not good. Sorry. Alright, 10. Oh, okay, maybe it's time, whatever. I will iterate to up to this number. Up to this number, this is approximate this one. Yeah, right. So now half here. I'm gonna use a half line digits by 2, right? It must be like round up, right? Plus 1, like 3. You want to construct a 3-digit number, you're gonna need one number, that is 3. Oh, 3 divided by 1. Okay. Okay. And okay, all right. Divide 2. Okay. Alright, then we're gonna do some long the sum here. Return the sum. We also need to write a function to check its palindrome number in the base k, right? So gonna write something to vector digits. How to convert? Okay, alright. 0. Check. You got number like 4, 1, and 1 is base 3. 3 is okay. 9 divide 2. You got like 4, 4, 4 is 1, 2, we got 2 is 1, 2 is 1, and this is 1, and 2 is 1. Okay, alright. 4 digits, so we're going 4 from, okay, alright. Okay, that's okay. Now we're gonna construct a number. This is the mean, long, mean one, like the one number is divided by half, so we're gonna got sorry, wait a minute. Okay, alright, +1. Alright. You know, if we got the size is too small, if we got like 4 numbers, then with a 3 digit number, you're gonna create a 2 digits, like from this one to this one, right? So the minimum number is like 10 power digits, right? 10 power digit. No. 10 power digits minus 1 to 10 power digits minus 1. Okay, now we're gonna write a power function, a simple power function. A simple only because it's very small. Actually, we don't need to use long here. So, but okay, don't worry about it. Alright. Double it, right? We need to double the number. This way, so it's gonna be, you know, if you got some like this, we need to add 2 numbers, so we multiply by 100. Alright, 100. I'm gonna use a base here. Alright, that's right. 100. Alright, so the font here is like the I base plus the reverse of it. We need to calculate the reverse of this number. So I'm gonna write functions like construct number, maybe it's kind of long h in the base, long base. Rest like base and y 10. We do it in reverse order. For example, you got 1, 2, so you're gonna get the mode here 2. So we multiply by 10 and add multiply by 10 and add 2. Gonna this, and the same at this. Okay. Alright. Okay, if is pairing from construct of I in base I'll refer n-1 and some okay. remember to check if and 0, so we're gonna break it out. Gonna return the sum. Okay. Return the sum. I just return here for worst case, it's required return. Alright, we almost done it. With iterate each number, but one to remember here is if digits is like it alters, okay, if 4 number is okay, but if it's 3 number only, it's an odd digit number, so we only need to replicate this one, okay. So we're gonna pass the digits here. Alright, if digits are an odd number, so we're gonna base initially base is like 100, right? But so we need to divide by 10, and we got 10 because we can only append the one here. So the number must delete the last number. Alright, delete the last number. Right. Check it out. Okay. Time limit. Alright. Maybe the check functions is wrong, so I'm gonna see out the is pairing wrong. 9 in base 2 is something wrong in the check function here. Oh, it's 1. Must consider here. So maybe this wrong is from the construct function. Alright, that's right. Okay, I can see it. You can see it's wrongly here. Give it a try. Come on, we're gonna got it. Voice don't touch too long. Maybe it's TLE. That's right. Sorry. Why is gonna create this number? I minus base, because base like 10, so we're gonna want 10, got this. And rest one. It's so true, man. It's so true. Ah, it's one here, and you're gonna. All right. Why multiply base here? All right. I can't believe I do this silly thing. But it may be correct here. Yes, this might be correct. What? It's gonna be correct. Yeah. Check it out. Harvest got a set. All right. All right. Okay. Just solve a half problem for the Monday here. Thank you for watching. Bye. Have a nice week.